Assalamualaikum warahmatullahi wabarakatuh. We are from DMK4A. We present about Unit 7.4, Choice of Stepping Motor Controllers and Driver, and Unit 7.5, Linear Stepping Motor. First, my name is Muhammad Nur Syafiq bin Abdul Rahim.
My name is Muhammad Nasrul bin Muhammad Siddiq.
We start with 7.4.1, PC-based/bus-based stepping motor controllers. PC-based or bus-based stepping controllers are standard PC card controller as shown in figure 2.29. A single computer can have single or multiple PC cards to run several stepper motor axes or machines simultaneously. One operator can run multiple machines from one station, and each machine can run several different axes. Since part changeover requires running a different program, changeover time is virtually eliminated. PC-based stepper controllers offers greater flexibility in terms of running different programs, monitoring different operation, networking, and software integration. This is example of circuit of PC-based stepper motor controller. The PC-based stepper motor controller is a combination of driver and switching circuit. The circuit is the actual circuit that drives the stepper motor, and the switching circuit decided how the motor should be driven. So it is basically the switching circuit that controls the motor. It can control three parameters of stepper motor: speed, direction, and numbers of steps. To vary the speed of the motor, have to vary the pulse repetition frequency, PRF. To change direction of the motor, you have to change the sequence of pulses applied to its coils by limiting the numbers of applied pulses. The right, the right, fig, the, the right figure is a typical stepping motor driver, and the left figure a 4-axis PC-based stepping motor controller.
7 Form 4 Form 2 Stand-alone stepping motor controllers. Stand-alone stepping controllers are generally found in automation systems which require position control with relatively few inputs or outputs control. Though more recent stand-alone controller provides I/O port extension. Stand-alone controller can provide sophisticated control whilst providing easy operator interface. The software program of operation is housed in the EEPROM inside the controller. This second controller are ideally good accuracy, where the inputs or output interface provides standard start or stop or automatic/manual operation. As an example, such stepping motor controller are commonly found in stand-alone machine or system. The system will have already been pre-programmed and instructions stored in the system ROM. The operator will only need to start or stop the system and perhaps make a few function selects. This is example of the picture.
PLC-based stepping motor controllers. This is the figure how PLC-based stepping motor controllers. PLC, the driver, stepping motor, and conveyor. PLC-based position module or stepping motor controller module can be used to provide good positioning control. Such stepping motor controllers are usually a software function call away, provided the following information are pre-programmed when calling the stepping motor into operation, such as function block or program block number, distance, velocity, acceleration. This is example of PLC programming in ladder diagram. This is example of the stepper motor controller in flowchart. And the right figure is PLC based stepping motor controller circuit diagram based on two-phase.
Linear stepping motors. Figure shows a linear stepping motor employing hybrid principle as found in an image scanner. This linear stepping motor is popular in application when linear displacement is required without the use of the linear slide and coupling. However, the motor torque is relatively low when compared to the conventional rotary stepping motor. The linear stepping motor is essentially a conventional rotary stepping motor which has been unwrapped so that it operates in a straight line. The moving component is referred to as the force and it travels along a fixed element called the platen. For operational purpose, the platen is equivalent to the rotor in a normal stepping motor, although it is an entirely passive device has no permanent magnet. This is the example figure about construction of linear stepping motor. The magnetic flux passing between the forcer and the platen give rise to a very strong force of attraction between the two pieces. When current is established in a field, when the resulting magnetic field tends to reinforce the permanent magnetic flux and one pole phase and cancel it at the other. Removing the current divides the permanent magnetic flux equally between the pole phase. By selectively repeating the excitation sequence, the forcer will continue to move. When the sequence of excitation is stopped, the forcer stops with the appropriate tooth set align. At rest, the forcer develops a holding force which opposes any attempt to displace it.
As conclusion, for PC bus base, implementing the simple multi-axis stepper motor controller system is accomplished using off-the-shelf equipment found at local electronics, retailers, and electromechanical salvage houses. The simple multi-axis stepper motor controller system is designed as an interactive educational for us in engineering and technology programs where it can be added as a self-contained lab or used as a supplement to existing courses to add diversity. The system also has application in industry as an industry tutorial on stepper motors and computer numerical control (CNC). Conclusion for PLC-based stepping motor controllers can provide quick solutions when it comes to programming the stepping motor and provide a easy interface to other automation system in practice. The PLC could simply send a signal, program or function call to activate the movement of the stepping motor to the desired distance. Thank you for lending your ears. That's all for us. Thank you.